Okay, let's get going right now. It's 5:26. This is video 103, and there's the aim. You can see one more time that I'm basically going to repeat what I did in the previous video, since the ideas are so important, and you'll definitely get an assignment later today that you can work on. Most of you should be able to do this math. So let's focus right away on what we're asked to factor. So that's the topic now. And you see here 30x squared plus 48x. And the basic idea is to extract everything that these two terms share. By the way, what is this? Binomial second degree, in other words, a quadratic binomial. It would be a trinomial if we had another term here, right? But we don't. So our task is to factor this. So I'm going to go back and do what I did yesterday again. And like I said, we get talking quite a bit about sixth grade math. If you never learned it or if you're confused by it, now you get another chance to practice. So what I'm going to do is I'm going to forget about the x's and turn my attention over here. Okay? So just like yesterday, I'm writing out a numeric expression. Doesn't equal anything. If you want, it equals 78, but no one's asking you what the sum is. That's the elementary school students. So over here, I have 30 plus 48, and I rewrote it in a different way. So in math, we say I factored out the 3. So it's factored. But what did I say before? It's not completely factored. Reason, 10 and 16 share another number. And so that's very important to see, because once we get that out, then we have it completely factored. So if I look closely again, it's 6 is the number that's the GCF, and I'll rewrite it like that, and 6 goes into 35 times, and at the same time, 6 goes into 48 8 times. So there we go. This is called completely factored. I mentioned that to you. So the question comes up, how do I find the GCF of 30 and 48? I forgot how to do that. Most high school kids do the math in their heads. They know their times tables and they figure it out. But I will briefly run down what you learned in 6th grade. For those of you who have a little bit of trouble with it, you're not sure. And when I make a up and down table, there we go. Okay, so that's called a prime factorization table. Half of 30 is 15. And then you ask yourself, is 15 prime or composite? And it's prime, and the circle numbers are all prime numbers. So then I write that 30 equals, we'll write it down here. There should be enough room so you can see everything. 30 equals 2 times 3 times 5. I put the little dots there to remind myself. And I go over here and I do the same thing, circling the primes. Many of you don't have to do this. If you can do it in your head, that's always preferable. Okay, so there's your so-called factor tree. And so I'll put a 30 here. And you can check that it equals that. And 48 here. See what I'm doing? And now I just write them sideways. And I'll get 6. And so they never give you really big numbers. You really have to be clear on that. And the numbers that match, their product is the GCF. And what's ever left over, which we talked about earlier, is 5. And then 2 times 2 times 8, 2, which is 8. Notice again, as I said, 5 and 8 are coprime numbers. Therefore, we know that this is done properly. So that's how I got it. I just showed you. Most of you won't have to do that. Maybe occasionally they'll give you some numbers that are slightly bigger, but most of you should be able to do that. And there's an internal check as well. Notice when I use 3, 10 and 16 are not composite, are not coprime. Excuse me. So they have to be coprime to be properly done. Now I'm going to erase this really quick, the 6th grade math I just did on the board. I showed you one way. There is another way, but it's more work, and most of you won't be needing that, but there is a way to find the GCF if you don't see it. And I just showed you that way. So now let's see the GCF, write that out, get out of the way here, the GCF is clearly 6, and the LCM is 6 times 5 times 8, which is 240 if you do the math. So there we go. We did everything we needed to do on a 6th grade level about this numeric expression. Okay, let's double check that it works. I take the LCM, I divide it by the GCF, and I'll get the terms, what I was looking for here. So the LCM is 240. I take the first term over here, 240 divided by 30 is 8, and that checks over here. And then I take the LCM again and divide it by the other original term. And if you do the math on a calculator or by hand, you'll see that it's 5. So again, 2 coprime numbers multiplied by the GCF gives you the LCM. The GCF you find typically by inspection, they call it, but you'll be required to do that in high school now. And the problem from a 6th grade point of view is completely finished. Okay? So I'm going to leave this here just for a second. I'll erase it in a minute. And I'll give you assignments today that you can work on. I haven't done 2 variables yet, but I'll get to that. And now I go over to our original problem. Okay? And there it is. 30x squared plus 48x. So I look at this and I already know what the numerical GCF is. So what does x squared and x share? Well, they share the x. And if I did it the way I did before, when I wrote that 30 equals 2 times 3 times 5, then I just add x. Well, what is x times x equals? X squared. And then I wrote out in 6th grade type of math, there we go. And there are the dots there. So I cancel what matches, and what cancels is the GCF, and what's open, there's a thing there right there. Okay, the circled ones are the leftovers, the residuals that I told you, and they have to be coprime, as I've mentioned a couple times. So there's the work redone from the numbers, and I'll leave it on so you can look at what I did. You'll see that what I did here and what I did there is not different at all. And I quickly erase it, and now I go to work on a high school level. I've picked up and absorbed 6th grade math, and now I go right to work here. 6x is the GCF. A lot of kids don't need all this explanation to see that. That's the biggest term I can extract from this binomial quadratic. What's left? 5x. Double check yourself. 6 times 5 is 30. X times x is x squared. And then, of course, 6 goes into 48x 8 times. You can check yourself. 6x times 8 is 48x. This is completely factored. If I had written this, 2x times 15x plus 24, well, this isn't going to work. Number one, it's not going to give me my LCM. And number two, 15 and 24 are not coprime. They both share the 3. So you have to understand that that's 6th grade math. This is not completely factored. Sure, it's factored, but in high school we care about completely factoring these expressions. Okay? So I quickly erase this, I wrote down. And now we'll do a quick check. We can go backwards. We notice that 5 and 8 are coprime numbers. I repeat again, that means only one. They share the 1 and only the 1. And now we'll figure out what the LCM is. So 6x plus 5x, and so it's 240x squared, just like we got before. And then you can divide this by 30x squared, which we'll be doing, and you get the same answer we got before, which is 30x squared, and that will be the 8 without the x. There it goes. And then we do it again, the LCM, divided this time by 48x. And when you divide that in, you'll get 5x, and there's the complete check. Okay? So that's called factoring. Monomial factoring, because the monomial that you extract from these algebraic expressions is only the GCF, fancy name for it. Okay? So that took me about 10 minutes. I'm going to do one quickly here that I wrote up, and I'm going to do it quickly, and then we'll follow this up further today before I give you assignments. And now I'm going to dispense with all the 6th grade stuff and just do one on a high school level. So it's very important to explain the underlying ideas of coprimeness, completely factoring something. So I turn my attention to this one here. Again, a binomial. And there it is. Everybody see it? And I'll work a lot faster this time. So I ask myself, without making a factor tree, which I'm always welcome to do, don't get me wrong, what number does 35 and 45 share? Huh? Come on, you guys can figure that out. That's 5. What's left? But most, and that's a 9. And I check myself right away. 7 and 9 are coprime because 7's a prime number, so it can only share the one of these two numbers. But what else do they share? It's pretty obvious that they share what? X squared. So I extract, we're using that word again like you would a tooth, right? And what's left over here? Well, 7x squared. Check yourself backwards. 5 times 7 is 35. X squared plus times x squared is x to the 4th, according to the product rule that you learned in 8th grade. And over here, I still keep the 9 that I extracted right away, but there it goes. Okay? So there you have it. Your GCF is 5x squared. Okay? I do the double check. 7 and 9 are coprime numbers, and the LCM is going to be, by the way, these two numbers have to be coprime, not with the GCF. The GCF is only taking out what everybody shares. So the same ideas that work in 6th grade work in freshman year of high school doing the regions, okay? Because, I say it again, these polynomials, these algebraic expressions are just representing numbers. Nothing more, nothing less, okay? And now we do the math with a little help of a calculator here. Since making mistakes, I try to cut down, and I'm not that good at it, is 5 times 7 times 9, and that comes out to be 315. Whoops, fix that up real quick. We're running out of time on the machine here. 315 x to the 4th. How did I get that one more time? I multiplied the GCF times the two coprime leftovers or residuals. And there I come up with that number there. And now all I have to do is divide this by 35 x to the 4th. And I end up getting 9. And then I take that LCM again. Can you see it? Yeah. I'll lower it a little bit. And that's x to the 4th. And I divide that by 45 x squared. Remember the quotient rule. If the base is the same, you subtract the bottom from the top. We'll be talking about that anyway. And when I do that, I end up getting 7x squared. So you can check yourself backwards to show you there's no difference between this and regular numbers. The math is complete, and we'll continue on this using 2 variables and maybe more terms, and then we'll have a couple word problems we can work out before we give you an assignment. Okay.